Hello and welcome to Sefasok Academy, the Intellects on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. In this video, we are looking at the Northwest 2024 Mathematics Paper 2 question 10 Roman 2, which is on curve sketching, which was on mini demands. So today I think that I have met up with the demand of curve sketching. So if you are new in this channel, I'll invite you to subscribe to the channel and turn on the notification bell to not miss any of our videos subsequently uploaded daily. I repeat the term daily. So the question read, sketch the curve 1 on x squared all over 4 for x not equals to positive or negative 2, showing clearly its asymptote, intercept and turning point. And the question was for 6 marks. So dear students, I'll invite you to follow me to the end, because not everything that I will say is necessary on writing. So generally, to sketch a curve, we need the parameters starting from the domain of function or domain of definition of the function. We have the intercepts of the function, we have the asymptotes, we have the turning points. From the turning points, we go to the variation table, and from the variation table, the graph is obtained. Good. So now the first thing that we'll do according to our function here is to find the domain of definition. And I've even given to you the domain of definition already, but it's not in expanded manner. They said x is not equals to positive or negative 2. So for x not equals to positive or negative 2, it means that the domain will have bounds at positive or negative 2. So to write the domain in spread form, it will be that from negative, you have from negative infinity to negative 2, okay, from 2 to positive infinity, then from negative 2 to 2, then from 2 to positive infinity. The domain is what? X is not equals to positive or negative 2. So it means that writing it in square bracket. Now I'm writing in square bracket here because to have it on our variation table will be very easy, and then to sketch our curve also will be very easy. So that's why I have it in square bracket. From negative infinity to negative 2, from negative 2 to 2, and then from 2 to positive infinity. So that is the domain of definition in square bracket. Now after that, we have the intercepts. For the intercept, we have two intercepts that exist because we are working on the two-axis graph or two-axis graph. So we have the y-intercept first when x is equal to 0. Y-intercept means that the point where the curve touches the y-axis, and at the y-axis x is equal to 0. So for x equals to 0, we are going to get y is equal to negative 1 over 4, for which the coordinates of the y-intercept will be 0 and negative 1 over 4. That is, x stands for 0 and then negative 1 over 4 stands for y. So now finding the x-intercept. The x-intercept is simply the point where the curve touches the x-axis, and when the graph or when the curve touches the x-axis, y is equals to 0. So it means that what? For y equals to 0, we are going to get that 1 all over x squared minus 4 equals to 0, which will imply that 1 is equals to 0, of course, is not equals to 0, so there is no solution for x. So if there is no solution for x, that means that there is no intercept, or there is no x-intercept. So now after finding the intercept, we can then go to our asymptotes. We have 3 asymptotes that exist, but in mathematics we limit ourselves to 2. That is, we have the vertical asymptote, we have the horizontal asymptote, and we have the slant or oblique asymptote. Now just one reminder, especially for the further math students following this video. In curve sketching for further mathematics, that is on a graph, we cannot have the 3 asymptotes at the same time. We can have 2. And the horizontal and the oblique asymptote should never be on the same graph, or can never be on the same graph. Either you have a vertical and oblique, or a vertical and horizontal, but never a horizontal and oblique, since both of them are competing, and also because both of them are gotten from the same manner. So now for the asymptote, I start with the horizontal asymptote. The horizontal asymptote, I can represent it as HA, and it is a point where y equals to the limit as x approaches positive or negative infinity of our function. So of 1 over x squared minus 4. Now to find the limit as x approaches positive or negative infinity of a function, of a rational function, we divide the numerator and the denominator by the x term that is having the highest power, and the x term that is having the highest power here is x squared. So I divide the numerator by x squared, I divide the denominator by x squared. So now 1 all over x squared as x approaches positive infinity or negative infinity. You see that word as x approaches infinity, 1 all over infinity is equals to 0 or approach 0. So it means that our horizontal asymptote here will be at the point y equals to 0. Now after finding the horizontal asymptote, we now go to the vertical asymptote. But the vertical asymptote simply occurs at the domain of the function. And now just as a small reminder, a vertical asymptote or an asymptote in general is a line that follows a curve to infinity but never touches the curve. So for the horizontal asymptote, we have what x is not equal to negative 1 over 2. That is for the domain. The vertical asymptote exists at the domain. So at the vertical asymptote will be what? At the point x equals to negative 2 and x equals to 2. Now also for a small exception here, an asymptote is true that is a line that follows the curve to infinity but never touches the curve, but there are some cases where the line or the curve crosses the horizontal asymptote, but it can never and ever cross the vertical and oblique asymptote. So the vertical asymptote is always at the domain. We have x equals to negative 2 and x equals to 2. So those are our two vertical asymptotes. Now after finding the vertical asymptotes or after finding the asymptotes all, we have that word. We can now go to the turning points. So it can also be called the turning points or stationary points. Now to find the turning points of the function, we differentiate the function. So differentiating this function here, we have a rational function. And to differentiate a rational function, we use the quotient rule of differentiation. So it means that f prime of x will be what? I maintain the denominator constant and I differentiate the numerator. Differentiating 1, I will have 0 minus, I keep the numerator constant now, which is 1, into I differentiate the denominator, which is x. When I differentiate x squared minus 4, I'm going to get 2x. So divided by the denominator all squared. That's all about the quotient rule. So I think I'll make a video on that, on quotient rule, so that you should have a more better understanding on it. So now after that, we have we simplify. We'll get that f prime of x is equal to negative 2x all over x squared minus 4 all to the power 2. So after finding f prime of x, the turning point occurs at f prime of x equals to 0. So at x prime of x equals to 0 or at f prime of x equals to 0, we're going to get that word. F prime of x equals to 0 implies that negative 2x all over x squared minus 4 equals to 0. We imply that word x is equals to 0. So that's why we implied. So the turning point is at x equals to 0. Now to find the coordinates of the turning point, we take this value of x and replace it into our function to get the corresponding value of y, to find what the coordinates of the turning point. So to do that, I first of all replace my function here. That is, I repeat my function f of x at f prime of x. Now I replace what the value of x in f of x here. So f of 0 will be 1 all over 0 minus 4, which will give me negative 1 all over 4. So it means that the coordinates of the turning point will be 0 and negative 1 all over 4. Now after finding the coordinates of the turning point now, and after finding the turning point, we can now go down to our variation table. To draw the variation table is very, very easy. Don't take it difficult, take it easy. I have the variation table like this. I draw my table. I have what? X, f prime of x, f of x. Then now here I lay out the domain. Firstly, I have from negative infinity to 2, that is, I have first of all negative infinity to negative 2, from negative 2 to 2, then from 2 now to positive infinity. But now there exists a turning point at x equals to 0, and x equals to 0 is in between this bound here. So I must have my turning point at x equals to 0. Now after drawing like this, after displaying the domain of definition of our variation table, we can now do what? We can now represent our vertical asymptotes. Vertical asymptotes are meant to be represented on the variation table, not necessarily for the horizontal asymptote. So now here we have what? F prime of x. This is our f prime of x here, and we have the boundaries from negative infinity to negative 2. Don't go far. You can take x equals to negative 3. You realize that what? Here I'm going to get what? Here the denominator always be positive since it is all squared. even if we have a negative number, the square will make it to be positive. And here, if the function is negative, take note. So it means that when I substitute negative 3, I'm going to get negative, that is, I will get 2 times negative 3, which is negative 6. Negative times negative is positive. So in this interval here, f prime of x is positive. Now from negative 2 to 0, I can substitute negative 1. When I substitute negative 1, the outcome result will be positive, because negative times negative is positive. Now from 0 to 2, I can take 1. When I take 1, the outcome is negative. Don't forget about the denominator, because it will always be positive. So when I substitute 1, the result will be negative. Then now from 2 to positive infinity, again the result will be negative. Now I'm done with f prime of x. I can now go now toward f of x. Now I'm going to f of x. The image of negative infinity of f of x gives us, which is our horizontal asymptote, so is 0. It is increasing toward the image of negative 2 from below of f of x. If you don't actually know what it means, or if you don't actually know how to get it, you take what, since negative 2 is on the domain, you take a number that is slightly less than negative 2 and very close to negative 2, that is negative 2.1. When you replace negative 2.1 here, the result will be what? Positive. And if it is positive, then it is positive infinity. So 0 increases to positive infinity. Now from above, negative 2 from above, okay, we have what? If you substitute negative 1.9, the result will be negative infinity, because here negative 1.9 all squared minus 4, the result is negative. So we have from negative infinity, it increases to what? It increases to the image of 0 in f of x was negative 1 all over 4. So to negative 1 all over 4, we are seeing that the range here, or the sign here, is minus. So it means that it is decreasing back to what? To negative infinity. So it's leaving from 0, that is, it's leaving from negative 1/4 again, and it decreases to negative infinity. That is 2 from what? From below. You can take 1.9. When you take 1.9, the result will be negative there. So now here we have what? Negative. It means that it's also decreasing. Now 2 from above, if you substitute 2.1, you have what? 2.1 squared is greater than 4. So the outcome will be positive. And if the outcome is positive, then it's positive infinity. So it leads from positive infinity, and it decreases because it's minus toward the image of positive infinity on our f of x is 0. So that is all for the variation table. Like I said, firstly, you display out your domain. If there is any turning point, you write the turning point in between the range as well. Now the f prime of x, the positive negative are indicating if the function is either increasing or decreasing. Positive means that it is increasing, negative means that it is decreasing. So now after that, we can now go to our graph. To draw our graph, I first of all have my axis. I first of all sketch my axis, and after sketching my axis, I represent my two vertical asymptotes, that is on negative 2 and 2. X equals to negative 2 and x equals to 2. Normally I'm supposed to write it up here. It's advisable to always write it. And now after the vertical asymptote, I have my horizontal asymptote at the point or at the line y equals to 0. This is the line y equals to 0 here. So now after that, I have what? The first portion of my variation table is from negative infinity, from 0 to positive infinity. And 0 here is what? And 0 for f of x equals to 0, that is x is equals to negative infinity. So it leads from negative infinity and increases to positive infinity, or it leads from 0, from 0 it increases to positive infinity. So what we are seeing, that it is avoiding the word, the vertical asymptote, since the vertical asymptote can never be touched the curve. So now the next portion of our curve is from negative infinity to negative 1 all over 4. This is 1 all over 4 here is the intercept. Now I'm supposed to mark something here. So it leads from negative infinity like this. It increases to 1 all over 4. It leads from negative infinity, it increases to 1 all over 4. And now from 1 all over 4, the third portion of my variation table is what? From negative infinity to, that is from negative 1 over 4 to negative infinity. It increases from negative infinity to negative 1 over 4 before decreasing back again to negative infinity. So this is how I represent it. From negative 1 over 4, it decreases back toward negative infinity. Now the last portion of my curve is from positive infinity, it decreases to 0. So it leads from positive infinity like this, it decreases to 0. So that is a graph of the function f of x equals to 1 all over x squared minus 4 of the Norwest Mock 2024 paper 2. So guys, we have come to the end of this video, and if the video was interesting to you, I'll invite you to like the video and share with your friends for them to be able to attain academic excellence, because you know that when you share knowledge with your friends, you also gain more, as you have more credibility with them, and they will have more ease to come and show you their question for you to solve for them. And when you solve repeatedly, consistently, you are more sharp for that particular subject. So I invite you to share the link massively, because many students found problem with this curve sketching, and you sharing it is grace.